On page 10, we're going to follow this idea. It's something we've already really just seen on the previous page. Anytime that it's raised to a fractional exponent, just like this exact thing as writing the index of that base rate. See how I can just use these interchangeably here? That's something that we're going to do. I'm not changing any of the numbers. Stephen, if you wouldn't mind just shutting that. I'm not changing any of the numbers. I'm just writing. Students, aren't these the same problem, even though it's using two different operations? That's what this is right here. Let's take a look at this one, letter A. It's in, so I need to write it in radical form. The question is, what goes in each of the boxes? June, help me out. There's three things here. There's an X and a 7. Pick one of those and tell me which box it goes in. The big one, huh? The little big boy. The exponent, right? The 3 goes as the exponent. Let me do this here. Let's put this one in GURPS. And then the 7, which is obviously the last choice, June, that we have, goes right there as the index, right? I didn't change any of the numbers. I just changed the location of them. What is this number, Maya? 3.5 as a fraction. Carson, are you able to turn it off? Thank you. What is 3.5 as a fraction? Not 5 over 2. That would be 2.5. 7 over 2, right? So isn't this number y to the negative 3/5 the same as to the negative 7/2? Can I not now do the same strategy that I just did? Y index of 2 and an exponent of negative 7. Students, where do negative exponents go in a fraction?
Inside or out? Inside? Outside?
Neither. Where do negative exponents go in a fraction? Right here for letters E and F. What would this be right here as a fraction? The square root of a to the 5th? Couldn't you use these same ideas right here to do that? I only see two things though. I only see an A and a 5. What's the third number that I'm missing? Where's the 2 come from? You're right, by the way.
It's like the index and
should it be on the base, the numerator, or the denominator?
on the denominator.
Denominator. Try letter F. While you try. Did you come up with this for letter F? Isn't 5 the index, so it goes on the bottom? Isn't 3 the exponent, so it goes on top? Should be a B right there. Sorry, that's a little bit non-B-ish. I changed letter G because you will see a problem on your next learning check like this, where there's 2 different radicands underneath the radical.
What's D and H?
We haven't gotten to, there's D, but we haven't done H yet.
Oh, I
Would you mind closing your computer, Stephen, so you can stay with us?
I did.
Wouldn't you have 2 separate fractional exponents for this? What would the denominator be for both? Don't they both have right there? It doesn't matter which order, but couldn't I put an x in the first one and a y in the second? But if I put x first, what has to be the numerator? It's x to the, right? What's the numerator for the y? Y to the power, right? So doesn't this have to be a 1 right here? So x to the 3/4, y to the 1/4. See how they have different exponents? Underneath, they have different exponents. Letter H just looks pretty similar, doesn't it, to what we've seen? Now, one of the reasons why I went on that little diatribe about my kids in their bunk beds to talk about negative exponents is, and I'm not saying this to blame anybody, but I've become increasingly aware that it might be class, and maybe just as a grade level, are not as strong. Saying that doesn't mean like, oh, I'm going home and saying how to do to say, hey, I got to get you ready for that. So with these exponent rules, this is something that we're going to do, but this is one of the reasons why I just showed a little bit earlier. What cut that I could do when I see like x squared times x to the 8th? What is the shortcut that I can do? I just add the exponents. It's like x to the 3/4 times x to the 7/8. Wouldn't that be a lot easier to use your calculator to add those exponents? Now that you know how to use fractions, right? Whenever I see two bases that are the same connected by multiplication, I can add their exponents. If I see a base right there and it has an exponent raised to an exponent, what's the shortcut? What do I do with those numbers? I multiply them, right? So can you imagine if you're multiplying fractions? 3/4, wouldn't that be easier in a calculator as well? Here's that negative exponent rule, right? If I have something that has a negative exponent, it just goes to the other side of the fraction. What do I do here? What is it? If I subtract it, 4 minus 6 is, where do negative exponents go? On the bottom of the fraction, right? Doesn't it make sense if I think problem a different way? How many more x's do I have on bottom? Should I have in my final answer 2 more x's on bottom? Right? Just another way of thinking about that. Could you imagine that subtracting exponents with a calculator would be a lot easier if they were fractions as well? Okay? So that's what I want to do here. Eighths. Didn't we just talk about how to convert? Right? Radical form to exponential form. What two things, or what would I do with 3/4 and 2/8? Would I add them using my calculator, or would I subtract them? It looks like they're being divided, so don't I want to subtract them? It says 3/4 minus 2/8. Oops. Hello. It's 1/2. Is that 1/2 on the top or the bottom of the fraction?
Top.
It's on the top. It's a positive, right? This says x to the 1/2 power, which really is just the square root of x, right? This is my final answer. Couldn't I convert that back to a radical? 3 raised to the 1/2 times 3 raised to the 1/4. Should I add those fractions or should I subtract them?
I think add.
1/4. Wasn't that easier than getting common denominators? That's 3 raised to the 3/4. Again, what I could do is put that back into radical form. Or I could have the 4th root of 27. Do you see how I got 27 there? 3 times 3 times 3. Letter C and D. Try those on your own. Think about it. One time we added them, the other time we subtracted them. Hey. Go for it.
I got this for B. Right here. There.
Okay. See.
I kind of lost track on D. Mr. Stair.
Students, in short, when you see a division sign, you subtract the exponents. When you see a multiplication sign, you add the x. Anytime you see a number raised to an exponent, you can use your calculator. Now, on letter E, before I even use my calculator, where is this number going to be on the fraction? So if I already know that, I really need to use the negative exponent. What number goes on bottom of the fraction? 1024, right? Or you could say, hey, I want to put 1 over 16 raised to the 2.5 power. And it doesn't look like this convert a fraction, or fraction, just because of how small it is. But that number, 16 raised to the 2.5 is 1024, so it's 1 over 1024. Letter F have a negative exponent?
No, it doesn't.
It doesn't.
A negative.
On the bottom of the fraction, or negative exponents? Negative exponents, right? Not negative numbers. When you started learning about negative numbers, like -5, that's not the same as 1/5. It's 5 to the negative first power is the same as 1/5. A number raised to a fractional exponent, I could just use my calculator. That makes sense, because isn't this really just the 5th root of 32 raised to the 4th power?
When I got that, it says error.
Ooh. Let me show it. Let me see how you put it in.
Like -32.
You might have to bring it a little bit closer so I can see the buttons.
I tap this button right here.
Okay? But it's not -32, it's 32. Students, remember, order of operations. Look at this problem here.
Oh, I see it now. I see it. Oh, wait.
Do I do the exponents first, or do I take 32 times the -1?
32 times -1.
I do parentheses, exponents, multiplication, division, addition, and subtraction. No! Have you ever met my Aunt Sally? Yeah! Yeah, have you ever met her? Well, oops, that's an evil laugh. Sorry about that.
Just like that one scene from Happy Gilmore, right?
Oh, I can't speak of that in public. You guys are going to start accusing me of killing people that I've executed my dear Aunt Sally. Right? Order of operations, PEMDAS, please excuse my dear Aunt Sally. Or, you know. Could I use the calculator for this one? Let's do it. Did you get this number with the calculator? You did not, did you? You lie through your face holes. This one right here. Where would this number be? 9 raised to the 3.5 power, but that number's on the bottom of the fraction. You still have it on? No, you didn't.
There's 10 seconds.
It was on there when I was talking about negative exponents and bunk beds. Oh, so it's still on then. You're admitting that? So it's over, basically?
No, it's in my game.
Well, of course they did. They're against the Big Ten team, aren't they?
Where is that?
Not here. Students, when you have a problem like this, put it on the outside of the parentheses, 16 to the first. Every number has an exponent, right? If you don't, it's a 1. Just like the index. If you don't see it, 16 to the first times negative 3/4. Y to the negative 8 times negative 3/4. Wouldn't this be the same as 16 raised to the negative 3/4 and y raised to the positive 6? Didn't I just multiply those together? Negative 8/4. This number right here, would this be on the bottom or the top of a fraction? 16 raised power. The number 8 is on bottom of the fraction. Same thing right here. 8 raised to the negative 1/3. X raised to the negative 5th. Didn't I multiply exponents by negative 1/3? That means that there's a 2 on the bottom. Again, I could just use my calculator for this. Negative 5th go. Does that stay on top? No, he likes the bottom bunk bed better, doesn't English? These are some rules, and I'm not saying this learned in middle school, but now instead of just integer exponents, positive and negative whole numbers, now we're doing fractions. Isn't this a lot easier to use with the fractions? Real quickly, students. If look at Carson go. Wait, what? How do I get rid of the square root sign? Well, but what do I have to do to make that happen? We know how to get rid of a square. Turn it off. Thank you. Square it, right? Square it. Square both sides. Doesn't that eliminate the radical right there?
Yeah.
Then how do I get x by itself? Divide then by 2.
X is 14.
Don't I get 14? 3 plus the square root sign of 2 times 14 minus 3. What should my final answer be?
14.
8. I'm checking my answer. I put 14 back into the original problem, and I could use my calculator to check it. Take a minute and see what answer you get here. Did you get 6? Right here. Letter C. How do I get that 3 on the other side? Isaac, why? Right.
Because the 3 is like adjacent to the parentheses that's being multiplied.
There is a multiplication sign between the 3, correct? So therefore, if that's true, we are going to divide it. So divide both sides by 3 equals 4. Now students, how am I going to get rid of this exponent? Not distribute. I cannot distribute an exponent when there's a sign on the inside. If it was just multiplication, I could. right? But remember, when we've ever seen problems like this, I cannot distribute the 2 on the inside of that. Students, isn't this problem right here, didn't this problem really have a 1/2 as an exponent? Isn't that what a square root sign really is? A 1/2 to cancel out a 2/3. Wouldn't I need a 3 sides? Aren't these simplified out? What could I do to make this problem a lot easier? What tool could I use? A handy dandy calculator? 8. If you do it this way, you get 8. If you do it this way, you get 6. Oh, you don't get 6, but there it is. You must use parentheses around your exponent. If you ever feel like you're not getting the right answer, I'm sorry, you got to get rid of the 1, my apologies. Then divide by 3. X plus 1 raised to the 3/5 power equals 8. What is 8 raised to the 5/3 power? No, it's not that big. It's just 32.
I got it. You just see. I've done like 6. I got 61 for that bracket.
It's due Wednesday at midnight. On your Math Excel, I'll have those posted on the Canvas page for the video here. All right, students, for the last 2 here, we're still going to be isolating the absolute value sign. So we're going to have the square root of x plus 7 equals x plus 5. We're going to be getting rid of that square root sign. And so we're going to square both sides. Remember, we got to do everything here. So recall, it's not just x plus 5 squared. I need to think about it written twice. So it isolates over here, right? The square root sign goes away. And this, if I square it, is just like that. Students, when we're thinking about this, I have an x squared. Anytime I'm trying to solve an x squared problem, I need to get 0 on one side of the equal sign. So I'm going to subtract x and 7 from both sides. That's plus 9x, and that's plus 18. Now I can factor, and I get a positive x plus 6 or negative 6, x plus 3 or negative 3. Now notice, students, it's asking me to check for extraneous solutions. So what that means is if I take this and I plug it into the original problem, is this a true statement? Right there. Looks like I have a 1, negative 6 plus 7 is 1, minus 5 is negative 6. Square root of 1 minus 5 is negative 6. That does not work. So this one right here, not possible. Let's try this one right here. Negative 3 plus 7 minus 5, and it equals negative 3. That's going to be a 4 underneath, minus 5 equals negative 3. Square root of 4 is 2 minus 5 equals negative 3. And that does work out. So negative 3, that is the only answer that we have. Go ahead and pause this video and see the last one. Now you can see this. Obviously, you can pause the video to see it. But notice we've isolated the x. We factored to solve. I checked both answers. This time the first one did, but the second one didn't. Remember, there's no rhyme or reason to which ones work and which ones don't. It could be both work. It could be both don't work. It could be one works and one doesn't.